So sketch the line that has a slope of m equals -2, so that's -2/1, and passes through the given point. The given point being this point right here, -4, 6. So if I want to sketch that out, my slope is -2. I'm going to go down 2/1. And just continue that pattern all the way till I get to the end. And if there's space to go backwards, I'm going to do that too. And so here's my line. So what's the y-intercept of this line? -2, right? So 0, -2. So the equation, if I'm going to write it in slope-intercept form, would be y equals -2, x minus 2. But today we're going to talk about a new form, point-slope form. And I briefly talked about it up on the board here, but let's actually write some stuff down. So this is going to be the format of our linear equations given a point on the line, other than the y-intercept, and the slope. So m is still representing the slope. If you see m in an equation, usually it's talking about the slope. x1, y1 is a coordinate. Oops. So that is going to be just some point on the line. So what we want to practice is making sure we're getting the signs right of the x and the y coordinates, because it is the opposite of what you actually see in the equation, because it is -x1 and -y1. So let's run through a couple here. So for number 1, let's identify the slope and the point. This is going to help us graph a little later too. So what's the slope? What's my m? Two-thirds, yeah. And then my point, my x1, y1, is going to be 9, 4. Okay, notice it's not -9, -4, even though you see minus minus up here. All right, so that's pretty much it. Okay, that's what we're going to do for the next couple problems. So what's the slope for number 2? -6. Yeah, so the slope is just whatever you see there. Okay, that's not going to have the opposite sign, just the coordinate. So my point on the line, what's the x value of the coordinate? Let's see if you're starting to get this. 3. And what's the y coordinate? It's +3, comma, +1, right? So that coordinate, and it'll just take practice to kind of get used to that, is these numbers will be the opposite of x1, y1. Right? Now 3 is a little tricky. You don't see any parentheses here. So if I were to throw in some parentheses here, without changing anything, what would I have to be adding or subtracting here? Like what is the same as not doing anything? You're adding 0, right? Yeah. So if you don't see parentheses there and it looks like it's kind of set up for a point and slope form, then that x1 is just going to be 0. So my slope is 3/5. It's my m value. And then my coordinate, my point, my x1, y1, 0, comma, -6. So that, all right, so let's just keep practicing here. So now we're going to go backwards. Instead of trying to extract the point and the slope from point-slope form, we're going to go the other way, and given a point and given a slope, write the equation. So I'll do one just to kind of show you, and then I'll have you help me in the second two. So the format we're using, maybe I'll write this up at the top somewhere, is, just as a reminder, y minus y1 equals m times x minus x1. So that's That's point slope form, as opposed to slope intercept form. All right, so we've got y minus 3, this is my x1, y1 right here, equals 1/4 times x plus 8. All right, notice how the 8 and the 3 have the opposite signs, what's given. All right, number 2. We've got y, and then what am I adding or subtracting to y here? So, yeah, so what should I write here? Plus 1 equals -2 times x minus 3. Yeah. And this takes practice, y'all. Don't get frustrated if it's not clicking right away. All right, number 3. Okay, so help me out here. Y what? Plus 6 equals 3 times x minus 5. All right, now on your quiz, the original instructions had you write an equation slope-intercept form given 2 points. On the homework, one of those points was always the y-intercept, right? But we want to get to a point where we can actually write an equation in slope-intercept form from 2 points where neither one of them is the y-intercept. Now, you don't actually have to find the y-intercept separately. I'm going to show you how we can use slope-intercept form to sort of morph it into, point slope form, morph that into slope-intercept form. Yes, sir. Sure. So I want to write an equation just like I did to in the problems in example 2. But I'm just given 2 points. I'm not given the slope. So what do you suppose we need to do first? Like if I'm trying to write an equation in this form, what's the one thing that's not given in question 4? The slope. Well, we don't have the y-intercept, but we don't really need it for this form, the point slope form. Okay, we just need a coordinate, and we've got 2 of those. We could actually pick either one, but what we're missing is the slope. So we've got to calculate the slope. All right, so let's calculate the slope real quick. What's my change in y? Plus 10. And what's my change in x? Minus 5. So 10 divided by -5 would be -2. So now I've got my slope ready to go. Now, my first goal is to get the slope. My second goal is going to be to write it in point slope form, the new form. And then I'll use point slope form to get it into slope intercept form. So it's sort of a 3-step process here. Find the slope, write it in point slope form, and then manipulate it into slope intercept form. So let's write it in point slope form. So which point should I pick? I've got 2 points on the line. Does it matter? Yes, or what do you think? So yeah, it doesn't really matter, does it? So let's pick, which one do you want to pick? 7-2 or 212? 212, all right. So we're going to use this point as my x1, y1. Okay, so now I'm going to start putting together my equation in point slope form. Y minus 12 equals my slope, which is -2, times x minus 2. So that's point slope form. If the directions just said write an equation that goes through these 2 points, I could be done. That's my equation. I found my slope, plugged everything in, I'm good to go. But unfortunately, the directions say to put it into slope-intercept form, the y equals mx plus b form. So this is not quite there yet. But we can get there by just doing a little bit of algebra. Okay, so it's really just 2 steps. It'll always just be 2 steps. The first step will always be to distribute your slope. Okay, so I'm going to distribute that -2. And then I'll have y minus 12 equals -2x plus 4. And if I'm trying to get this into y equals mx plus b form, what's my next step going to be? So I'll erase this, but this is what I want it to look like. Right? Yeah, just add 12. So that's your second step. First step is to distribute, and the second step is to get that y1 over to the other side, to isolate y. So yeah, if I add 12 to both sides, and you're only going to add it to that constant. It doesn't have an x, so you don't combine it with a term that it is not like. And we get y equals -2x plus 16. So we've gone from 2 points to finding the slope to writing it in point-slope form and then manipulating that into slope-intercept form. Now the next 5 problems are basically doing the same thing. So I'll go through them, a little quicker each time, but the process will be identical. All right, so make sure you ask if there's anything that you don't understand, or if I'm going too fast, slow me down, or anything like that. Let's look at number 5. We've got 2 points. Our ultimate goal is to get it into slope-intercept form, but first we've got to find the slope, and then we'll put it into point-slope form, and then we'll get it down to slope-intercept form after that. So let's find the slope first. My change in y is 3. My change in x is 6, so my slope is 1/2. Now, I could pick either one of these points as my x1, y1. It really doesn't matter, but I'm going to go with the second one just because there's no negatives in that. I don't have to worry about that. So I get y minus 1 equals 1/2 times x minus 12. So again, that's point-slope form. We got the point and the slope. Now I'm going to manipulate it into slope-intercept form by distributing the 1/2. So y minus 1 equals 1/2 x minus 6. And then what's my last step? Add the 1, right. So you see how the process is the same? And that's going to be the same for all of these, really. We'll get a lot of practice in this. Any questions so far? All right, well, let's do the next one. Change in y is -2. Change in x is 8. So I think that reduces, yeah? -1/4. Now I'm ready to go ahead and put it in point-slope form. Ooh, which point do y'all want to use? It looks like you got one positive, one negative. I don't know that one's going to be any more useful than the other, so you just got to kind of pick one and go with it. So the first one? All right, yeah, sure. Let's use the first one. So we got y minus 1 equals -1/4 times x. What's the final number in here? Plus 4. Good. Yes, sir. Sure. So I've only got 2 steps left. Distribute, combine like terms, basically. Distribute the -1/4. gives me y minus 1 equals negative 1/4 x. What's a fourth of 4? Yeah, 1, right? So minus 1. Then we're going to add 1 to both sides. So we get y equals negative 1/4 x, I guess plus 0, right? But we don't need to write the plus 0. So that's our equation. And this is a sort of a special linear equation because the y-intercept is 0, meaning this graph goes through the origin. Do y'all, it's been a long time. Do y'all remember what phrase we have that means that, where it goes through the origin? It's, well, all of these are linear, right? They all create lines. But there's a special type of linear equation that goes through the origin. Basically, we say that the function has direct variation, right? So I'm going to just make a note of that so we don't forget about that. So I know that was our first day of this unit. Direct variation. So anytime we get that, I'm going to write that down over and over again, so we hopefully will remember that by the time our test, which isn't even until next week, yeah. So, any questions? All right, well, let's knock out a few more examples. Number 12. Now these are coordinates written in function notation. So if it helps, you can rewrite it as a point. You don't have to, but this is going to be negative 3 comma negative 1, and this is negative 2 comma 4. So if it helps to rewrite it as a set of coordinates, you can go ahead and do that. It's not something you have to do if you understand the function notation. But let's calculate the slope. So my m equals what? Change in y is plus 5. Change in x is plus 1. So 5 over 1 would be 5. So there's my slope. We got 2 coordinates we can pick from. Which one do y'all want to use?
Would it be easier to do one with 2 negatives?
Yeah, I mean, it really doesn't. I mean, you have to switch the sign anyway, so it really doesn't matter. Honestly, you could pick it at either point, and I don't know that the difficulty is going to be significantly different. So, which one do you want to do? Second one? All right, so we'll go with the second one. So y minus 4 equals m, or 5, times x plus 2. So we distribute the 5. Y minus 4 equals 5x plus 10. And then what's going to be our final answer here? Let's see if you can go straight to it. Yep. So you add the 4 to both sides and get y equals 5x plus 14. So yeah, let's turn off. So now we're going to get to the graphing piece of this. So let's start by writing the equation. We're given a point and a slope, so we're going to write it in point and slope form, obviously. Y plus 4 equals 2 times x minus 2. So if you're given the point and the slope, it doesn't really help to write it as an equation. I just want us to keep practicing that so that we can make sure to get the signs correct, because that's really going to be the thing that throws most people off. So to graph it, though, we're going to graph it the same way that we graphed the very first problem on this notes, today's notes, where we just plot the point that's given. So your plotting skills need to be on point here, pardon the pun, and then use the slope to find the line. So let's plot 2, negative 4. So take 10 seconds to plot 2, negative 4, just for your own sake to know whether or not you know how to do that. All right, it should be right here, 2, negative 4. Now, if you got it in the wrong spot, maybe we need to practice plotting a little bit more. But hopefully you got that where it's supposed to be. The slope is 2, which as a fraction is 2 over 1. So we'll go up 2 over 1, up 2 over 1. The slope's positive, so it should be going up from left to right. And so your line looks like this. Okay. So notice that we didn't really have to find the y-intercept here. We just used the point and the slope to graph the line. Any questions so far? All right, let's try another one. The slope is 2/3, point is -3, 1. So just for practice, let's write the equation. Y minus 1 equals 2/3 times x plus 3. So I'm going to start by plotting the point. Take like 10 seconds and see if you can plot that point correctly. -3, 1. Should be right there. The slope is 2/3. It's positive, so again, it's going to be going up from left to right. And we're going to go up 2, we're going to rise 2, run 3. Rise 2, run 3. Rise 2, run 3. And you can continue that pattern backwards, I think, 1 point. So yeah, but we are starting, here. Any questions about that one? All right, number 17. We've got 1, -5 with a slope of -3. That means I need to go down 3 over 1. But I'm going to be a little off the graph, so let's take it backwards. All right. So 1, 2, 3 over 1, 1, 2, 3 over 1, and so on. You want to fit as many points as you can on there. The more you can fit on there, the more accurate your graph is going to be. And oh, we didn't write the equation here. Y plus 5 equals -3 times x minus 1. On this table, you're given the point and the slope, and you're supposed to fill out the rest of the row. So the first thing we want to do, I think, is let's write the equation over to the left in point-slope form. Notice over to the right, the column says to write it in slope-intercept form. Now what I'm going to show you through this table is you kind of want to wait to do that until last, because sometimes it's easier to just look at the graph and write the equation in slope-intercept form. Because if you can just identify the y-intercept from the graph, then you don't have to do any of the algebra. But if it's like off the grid or it's like a decimal or something like that, that's when we want to go back and actually do the algebra. So it all depends on what's easier. So let's start by writing the equation in point-slope form. So we've got the slope and the point. We've done about 20 of these so far, so let's see if we can do, I don't know about 20, but 17, I guess. Y minus 3 equals 5/2 times x minus 2. So that's the equation in point-slope form. We do need to put this in a slope-intercept form like we did a couple of the equations earlier. Not yet, but we will need to do that eventually. So let's look at the graph then. We'll start by plotting the given point, 2, 3. Now the slope is up 5 over 2. Obviously we're not really going to be able to fit like this point on the grid, so let's go the other way. Okay, 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, and then that's about all we can fit on here. Yeah. So here's the question I'm going to ask you, and this is the question you should ask yourself once you've got the graph down and you need to write it in slope-intercept form. In this problem, will it be easier to like distribute and then move the 3 over, like find it algebraically, or can we just look at the graph and find the y-intercept? So what do you think is going to be easier in this case? Probably the graph, right? Like what is the y-intercept? -2, right? So we don't need to go through the algebra to find it. We could just see it visually. So in that case, like you don't have to go through all that work to get it from one form to the other. You just go ahead and write your equation. Y equals 5/2. The slope will be the same. You don't have to worry about that. It's just a matter of finding that y-intercept, -2, which we can get from the graph. Now you don't have to write this down, but if I were to go ahead and actually solve this, like distribute this, 5/2 times -2 would be -5, plus 3 would be -2, I'd get the same answer. So if you like doing the algebra side of it, you can keep doing that. There's no reason not to. All right, let's try the next one. So first we're going to write it in point-slope form, then we're going to graph it, and then just sort of judge which way will be easier to come up with slope-intercept form. So here we've got y minus 1 equals -1 times x plus 4. So we'll go ahead and graph. The point is -4, 1, and the slope is -1. So that means it'll be going down from left to right when the slope is negative. We'll go down 1 over 1. There we go. And you'll see this pretty often. Yes, sir? Sure. You'll see this pretty often, but you know, just like the last case, what's going to be easier to what method will be easier to find the y-intercept here? The algebraic method or the geometric method? Where you just look at the graph, or do we want to go through the algebra? Yeah, let's look at it geometrically, right? Just where does it actually cross the y-axis? And then we don't have to go through all the algebra. So it'd be y equals, the slope is the same, okay? Again, you don't have to change that. -1x, and then what's the y-intercept in this case? Yeah, -3, so -3. Kind of hoping we hit one where we have to do it algebraically just so you can see it. But we already did, what, 5 examples of going algebraically, so I don't know if we need to do a whole lot more. All right, so let's hit up the next one. Y plus 3 equals 4 times x plus 2. Okay, so we'll go do the graph. The point is -2, -3. Slope is 4, so I'm going to have to go up 4 over 1. Up 4 over 1. Up 4 over 1. Can't go backwards, so that looks good. What's the y-intercept here? So y equals 4x plus 5. Okay. Any questions so far?